Please welcome Catherine Fletcher, Science Creates Ventures.
Hello, I'm Catherine, and I'm an early-stage deep tech investor from SCVC, formerly known as Science Creates Ventures. And I'm here today to nominate Kelpi. So at SCVC, we invest in category-defining technologies that cross disciplines and has any application towards human health or the health of the planet. I'm really excited by Kelpi because for us, they are the epitome of our thesis. So they have a technology breakthrough which has proven really, really elusive. And that is a biomaterial with a high-performance water barrier that also retains genuine compostability. And they're now working with global brands to make single-use plastics a thing of the past. And I'm now going to hand over to Neil to tell you a little bit more about how they are solving one of the world's biggest challenges. That's too fast.
Breaking the wall to a high water barrier. Biodegradable polymer. Neil Morris. Kelpi.
Thank you, Catherine. We're here today because of a global plastics catastrophe. It's the only way to describe the situation that we face because of our over-reliance on cheap, adaptable, barrier-performing fossil fuel plastic packaging, which can persist for hundreds of years in the environment. And even where it is recycling and only a small amount is being recycled, we're still facing the problem of microplastic pollution. The first generation of bioplastics, yes, they were renewably sourced, they were unrecyclable, but they lacked a water barrier, they lacked end-of-life equivalents. We were still reliant on this fossil fuel plastic solution. So the scientific challenge, the science problem we face, is how to take a renewably sourced material and deliver it with an excellent water barrier, which is what our industrial clients would need, with the kind of performance that will still, despite that water barrier, break down in seawater, in compost, in soil, will be recycled at a higher rate. This is Kelpi's technology breakthrough. We've developed a coating for paper, for card, for fiber, wet molded and dry molded fiber. That coating has a world-leading water barrier, yet it breaks down fully in seawater. It's recyclable with paper and card. We start our journey with seaweed. From the seaweed, we extract carbohydrates and we functionalize them using plant-based oils. This allows us to build in the kind of bonds that will be seen naturally in nature. And that's key to taking a renewable feedstock, seaweed, going through a low-carbon process and rendering at the end a compostable material that is fully marine safe, will break down in seawater, leaving no microplastics and no toxins behind, and is fully recyclable. And this is a commercially valuable problem we're solving. Some of the world's largest companies are looking for solutions. L'Oreal, under their Beyond Plastics program, set out inviting 140 bidders worldwide to pitch for their sustainable packaging solutions. Kelpi was selected as the winner, and as a result, we're now in a paid R&D contract with L'Oreal. Likewise with Diageo, one of the world's largest drinks manufacturers. They too selected Kelpi through an open procurement process, and we are now working with Diageo in paid R&D contract work. DS Smith, one of the world's largest packaging concerns, also selected Kelpi from a field of 10 startups to work with them on sustainable packaging, as did Stora Enso, another huge global Scandinavian packaging concern, selecting Kelpi over all our peers. Key to our success has been that fusion of science and business that we see as one of the greatest accelerators of change at the very time that we need this change delivered. Our team of 15 staff comprises world-leading scientists supported by expert entrepreneurs. I myself am a serial entrepreneur with a successful exit behind me. We have PhDs joining MBAs to create the magic that we've built here. And that team has been key to us delivering on a series of milestones across the commercial area and the product area. I've already mentioned 2 of the contracts that I can talk about in public now, but we're on the verge of signing a 3rd with a major supermarket group. The partnership with DS Smith, the packaging giant, will progress forward at the beginning of next year, and that will allow us to ship our first product at scale at the start of 2025, exploring a business model of IP licensing combined with third-party manufacturer, tailored to meet the exact requirements of the clients with which we're in collaborative co-development at present. We have a portfolio of patents that we've been rolling out worldwide to protect our innovation. And alongside that, we've been scaling up first to 10, now to 100 kilogram pilots to prove our production capability at scale. And those will go to 1 ton pilots in the first half of next year. And key to going to market is our achievement of regulatory approval as a food contact material, vital to be able to package not only food and drink contents, but also cosmetics and personal care. The business has been funded to date from a Seed 1 funding round led by SCVC. You heard from Dr. Catherine Fletcher just now. And we will be early in the new year opening a Seed 2 round where we'll be seeking £3 million, €3.5 million for the runway to achieve our Series A funding round, which will open late in 2025. So that then is how we propose to open up the huge packaging opportunity with the world's first truly sustainable material matching fossil fuel plastic performance.
Perfect ending, no? I think that's great. Thank you. On point. This is great. So, are you ready for questions? Let's go, because countdown is coming now down from 4 minutes. Who would like to start? Jury, you have priority? I don't see anyone from the... Yeah, sorry, but you will be next. Yeah.
You talked about low carbon production. Does this include also the farming for the seaweed?
So we are not ourselves seaweed farmers, but we work very closely with those that
But
do.
in the calculation of the low carbon production, this is all included.
We have already conducted a full LCA, a life cycle analysis, which allows us to measure carbon through the process. That is particularly dependent on exactly how the seaweed farms particularly dry their seaweed, which can be in cooler climes an energy-intensive process. We are sourcing our seaweed predominantly from warmer climes where the drying is a much less energy-intensive process. But yes, our LCAs will look at the entire life cycle.
Sorry, yeah, so, okay, well, yes, sorry, the jury had a question first. I don't forget you, sir, please.
I got a question regarding your business model. You have been mentioning that you're doing licensing and third-party production. So what it doesn't exactly mean regarding your patent portfolio? You have 2 or 3 patents granted. So for IP licensing, you most likely need a worldwide, really protective patent portfolio. What is the strategy going forward there?
That's right. So you saw in our timelines that it'll be early 2025 before we're at scale producing our materials for our clients. And by that time, our patent portfolio will have been rolled out worldwide. We're being advised by one of the world's leading patent experts in this area, who's worked himself in the packaging industry on patents and patent protection for some time. So that's key to a patent strategy that allows us to be able to offer to some clients the IP licensing model, those particularly with the huge scale like L'Oreal that would require that approach, whereas for others who want us to produce the material ourselves, we can use a third-party manufacturing model. What we don't do and what we're not seeking is the investment to build our own plant. That's a different sort of business model and not one that we're following. But you're absolutely right to say the patent portfolio is vital to our success, and that's why we've built up, rather than a single patent, a portfolio that will protect our innovation worldwide.
Good. Okay, short one. Yeah.
How can you be sure that the breakdown products of your material are less harmful than microplastics?
So In the audience with me today is Dr. Stephanie Federley, who's our Chief Scientific Officer. Stephanie has been leading a team in the lab that is making sure that we assess the end-of-life outcomes. We've got marine degradation experiments that we've been running in the lab. And in addition, we were also able to send our materials to the world-renowned Seattle Aquarium in the northwestern US, where they conducted a year-long assessment of the marine biodegradability of our materials. That was part of our participation in the Tom Ford Plastic Innovation Prize, which supported that.
Okay, just want to make sure. Did you want to ask a question? No, sorry, I have with the jury first.
I see this one.
Yeah, yes, you wanted to ask a question, no? Yes, please, she was the first one. Thank you.
Yeah, I was interested in the cost competitiveness to plastic and also the potential of scaling.
Yes, a very good question, if I may say. So we've been acutely aware from the outset that by working with the kind of clients that we are at the moment and those that I'm not able to currently mention but with which we're in advanced discussions, we need to be highly cost competitive. Right now, our materials come at a premium to fossil fuel plastics. Why? Because they've had 70 years of cost optimization invested in them. It will take time for us to be able to achieve parity. We do see that happening in due course, but to begin with, as we go to market, we're working particularly with brands that recognize that there will be a premium in the early years over and above what's currently achievable for fossil fuel plastics.
Okay, very last question, super short. We have 15 seconds left, but please, if you want to try this. The person here at the front? No, okay, well, I'm very sorry, we have 5 seconds left. So you will have to discuss this in the coffee break. I'm sorry. Sorry, thank you very much. That was great.
Thank you.
You can take your stuff.